Welcome everyone. This is a video review of what we went over in class. Today we're going over 1.1, graphs and models. This is pretty much the introduction you need before you get to calculus chapter 1. So today what we're going to be going over is very simple stuff that you've learned in algebra. And we're going to bring it all the way up to pre-calc throughout chapter 1. So we're going to learn how to sketch the graph of an equation. We're going to remember how to do this stuff. Find the intercept of a graph, test the graph for symmetry with respect to the x and y axes and the origin, find the point of intersection of two graphs, and interpret mathematical models for real-life data. Okay, you already know how to do all this stuff. Quick little review. Always good to review before we get into the hard stuff. Now, once again, this stuff actually is not calculus. It's just a review of stuff you're going to need in order to solve calculus. A bunch of simple things. So we're going to start with the simplest of them all. Bring it back to middle school. The graph of an equation. Sketching a graph by point plotting. So, first off, if I want to sketch the graph y equals x squared minus 2, what would I do? I have my x values and I have my y values. So, how this is going to work is you guys are going to try all these problems, and then I'm going to explain them. But as you try them, obviously you're going to pause me. Okay? So, I'm just going to get through and just go straight through the lesson. And you can follow along in your workbook as I do this. So, x is -2. In order to find y, what you do is you just plug it in. So I have the equation y equals x squared minus 2. So y equals -2 squared minus 2. Negative number squared is positive, so that becomes 4 minus 2, which is 2. Now what you do is you're going to take the next one. You're going to take -1. You take -1 and you plug it in. -1 squared is... sorry, I'm just putting my thing. Right. So you have your xy's right here. X value is the value you go left to right on the axis. Sorry. Y value is the value you go up and down on the axis. So this means you go left 2 for the x, up 2 for the y. So there's your first point. Alright, that's plotting points. Next thing, you have your -1. Once again, you take your -1, you're going to plug it in. -1 squared is 1. 1 minus 2 is -1. So right here, I'm going to go 1 to the left and 1 down. Right here is 0. 0 squared is 0 minus 2 is -2. 1 squared, 1 minus 2 is -1. 2 squared, 4 minus 2 is 2. And 3 squared minus 2 is 7. Alright, so why don't you guys just plot the rest of these points. -1, -1. 0, -2, 1, -1, 2 over, 2 up, 3 over, 7 up. And your graph is a parabola. Okay? That's it. Anytime you have a squared value, that becomes a parabola. Got it? Easy, right? This is not how easy class is going to be, but nice way to warm up the year. So now what I want you guys to do is look at problems A, B, C, and D, and list the x and y intercepts of those problems. Who took my pointer? Uh-oh, there's a car going on. Alright, so, next one, your x-intercept here, there is none, because this graph right here never crosses the x-axis. Y-intercept, 1, 2, 3, 4. So it would be 0 to the left and right, because y-axis always has an x value of 0, and then 4 up. This one right here, you can actually have 1, 2, 3 x-intercepts. All right, between 0 and -1/2, 1/2 is -1/2, 0. The y values for x-intercepts is always 0. 0, 0, your origin, and 1/2, 0. Your y-intercept, it only crosses here once. It happens to be the same as the x-intercept, which is the origin, which is 0, 0. Anytime you have an x-intercept at the origin, obviously the y is going to be there as well. Over here. All right, let's find the x-intercept of this one. It crosses one place, and that one place is right there. That is 3, 0. Y-intercept crosses in two places, 0, 1, and 0, 2. All right, and for problem D, that circle, even though that technically is not a function because we'll get into that later. There is no x-intercepts and there is no y-intercepts because the graph never crosses the axes. All right, good. Find the x and the y-intercepts of this graph, but now we're going to do it numerically. The graph is just there to help you guys out in case you need to do it the other way. So the way this works is fairly simple. What you're going to do is set y equal to 0 to find the x-intercept. Now when you set y equal to 0, it's actually very simple. Wherever you see a y, you make it 0. So 0 equals x cubed minus 4x. So step number 2 here is very simple as well. You're going to factor in order to solve for x. So you take an x out of both of them. So x cubed divided by x is x squared, 4x divided by x is negative 4. Now you're going to set both of those pieces equal to 0. X equals 0, well that's one of the intercepts. And then x squared minus 4 equals 0. Add 4 to both sides and take the square root of 4 to get a plus or minus 2. So you actually have 1, 2, 3. So x equals 0, 0 is one intercept. Negative 2, 0, and positive 2, 0. So those are your 3 x-intercepts. All right? Y-intercept time. So another way to do this, just real quick. Say you didn't want to factor this and add the 4. You can actually factor this because it's a perfect square. X plus 2x minus 2 equals 0. X plus 2 equals 0. X minus 2 equals 0. And you would still get negative 2 and positive 2 as answers. So this way or this way, either one is okay. You do not have to do it both ways. Y-intercept. Set x equal to 0. All right? So this is pretty easy. Set both those guys equal to 0. 0 minus 4 times 0. Y equals 0, which is your origin. If you want to check your answer right here, my x-intercepts, you can see, that's with the graph. They fall in the line. And my y-intercept right here is also right on the line. Okay? That is finding intercepts of a graph. You good? All right. Now we're going to roll right into symmetry. Now symmetry, there's 3 types. Pretty much what symmetry means is the graph is almost like a mirror of itself, okay? It's almost like a reflection, if you guys remember that from geometry. Now first off, if you're going to have an x-axis symmetry, you need to know where your x-axis is, okay? So in this case, your x-axis is where? It's the one going left to right, the horizontal axis. Right, so this is pretty much my x-axis. So symmetrical over that axis, or sorry, y-axis, I'm doing the next one. So your y-axis then would be up and down. So you're going to pretty much reflect over your y-axis. All right, so instead of being negative 5, up 2, you're still up 2, but you're not negative 5, you're going to be positive 5. So what do you think we're going to do here? What are we changing? We're changing our x value, and what are we doing to it? We're changing the sign. So the formula for y-axis is negative xy. So all you're in a sense doing here is replace a what with what? When I point to you, yell your answer on your own. You're by yourself. No one's going to say anything. Replace your x with a negative x. Very good. And then the 2 equations after you do this, your original equation and your new equation have to be the same. So they have to be equivalent. So you just replace the actual letter x with a negative x. And when you solve the equation out, when you reduce it, your equation should be the same. All right. Now we have our x-axis, our horizontal axis. So we're going to reflect that over your x. All right. And instead of being negative 5, 2, we're still negative 5, right? But now instead of being up 2, we go down 2. So it's negative 2. So the x stays the same. It's still both negative, so x stays the same, but y changes its sign, so it's x negative y. So what are we replacing here? We're replacing the y with a negative y, and our equations are equivalent. Good job. See, you didn't need to be in class today. Origin. What do you think you do with the origin? You're reflecting it over the origin. You're actually reflecting it over a graph when you do this. That is this graph right here. You're reflecting it over the x and the y-axis. So you're reflecting over the graph x equals y. All right? It's just a graph that goes through the origin as a slope of 1. So you reflect it here and down here. So what do you think our new point is? If you said 5, negative 2, you were correct. All right? So what are we switching here? We're switching the x and the y. Oops, that should be a blue. So you replace the x with a negative x and the y with a negative y. And the 2 equations end up being equivalent. Not too tough, right? Let's see. This is probably the toughest of what we're doing. Test the graph for symmetry. 2x cubed minus x. So, first thing you're going to do is you're going to replace all the x's with negative x's. So we're going to test for the y symmetry first. Y, you replace the x's. X, you replace the y's. Okay? Origin, replace both. So anywhere you see x, you're going to put in negative x. So 2 negative x cubed minus negative x. Now, a negative number to an odd power stays negative, and a negative times a negative is a positive. So y equals negative 2x cubed plus x. Are these two equations the same? Well, I don't think they're the same, do you? No. They're not equal, they're not equivalent, so they are not symmetrical. Okay? They have to be the same. Got it? Let's replace the y's. So, this just becomes negative y equals 2x cubed minus x. So, if you want to make it y equals, it's always easier just to make everything y equals, so change all the signs, because we just really care about the second part. So, we multiply everything here by negative 1, change the sign, change the sign. Are these two equations equal? No. Positive, negative, negative, positive. Not equal. So, not symmetrical. See? Very difficult. Not difficult. Let's do the origin. So upon doing the origin, we're going to replace the x and the y. So, negative y equals 2 negative x cubed minus x. Alright? This becomes negative, this becomes positive. Now look what happens here. Our y is negative, this is negative, this is positive. So, obviously right now they're not equal, but we could change everything here. Okay, so we're going to change all the signs. So I multiply this whole thing by negative 1. If I multiply both sides by negative 1, the equation stays the same. But then at least I have y equals positive into a negative 2x cubed minus x. So is this and this equal? Yes, they are equal. Since they're equal, that means they are symmetrical. So it's symmetrical about the origin. Alright, nothing to it. Number 5, test the graphs. So we're going to test some symmetry here. Y-axis first. So I want you guys to do these two problems. Alright, you should be done. X-axis, remember, you're going to replace the x with a negative x. Y equals negative x squared plus 6. Now a negative number squared is positive. So y equals x squared plus 6. What do you notice about these two equations? They are indeed equal, so it is symmetrical about the y-axis. Now you can be symmetrical about both. It is possible. X-axis, let's see. Replace the y with the negative y. Negative y equals x squared plus minus 6. So I'm going to change all the signs. Y equals negative and a positive. Obviously these two are not equal, so it's not equivalent to the original. So it's not symmetrical to the x-axis. And then you got your origin right here. I'm going to flip them both. Negative y, negative x squared minus 6. This stays negative. This becomes positive. So once again, we want the y equals just because it's easier that way. You don't have to do it, but that's my personal preference. So I change every sign. Y equals negative x squared plus 6. Very close here, but these two signs are indeed different. So it is not equivalent to the original, not symmetrical about the origin. All right, number 6. Good, you're done with it. Let's see. When you replace the y-axis, x goes to a negative x. So you got negative x over negative x squared plus 1. Y equals x over x squared plus 1. And I just made this whole thing out front negative. If you want to make the numerator negative instead, that's fine. Obviously, though, you have too many negatives down below. Not symmetrical. X-axis, we change the y. This one's pretty easy right off the bat. You get negative y equals this. So if I move the negative just to the other side, multiply both sides by negative 1. Not symmetrical. So let's see, the origin has to be symmetrical. It doesn't have to be, but it may be. All right, let's see. We're going to switch them both. Negative y, negative x over negative x squared. Negative y equals negative x over x squared plus 1. Let's multiply both sides by negative 1. Becomes a positive. Oh, you don't have to change all these signs. This drags out front, so these just both become positive. So you look at y equals x over x squared plus 1. Y equals x over x squared plus 1. They are indeed equal, so they are symmetrical. All right, so there you go. There is graphing symmetry. Got it? One day down. That's what day do. Now what we're going to do is use intercepts and symmetry to sketch a graph. Now, this is also fairly simple, so we should do all right. So first thing, the intercepts. Once you guys find the intercepts, this is just bringing up everything we did so far today. So find the x-intercept. You set y equal to 0. X squared minus 0. X minus 0 squared plus 1. X equals 1. Sorry, equals 1. So it's 1, 0. 1 over 0 up. To find the y-intercept, you set x equal to 0. You end up with negative y squared equals 1. Move the negative side. Y squared equals negative 1. What's the square root of negative 1? Undefined. The square root of any negative number, hopefully you guys remember, is undefined. So that means no y-intercept. All right? So far we got that going. Let's see if there's any symmetry right here. Switch your y to a negative y. And you get x squared minus y squared equals 1. They're equal. So it is symmetrical about the x-axis. That's good. Check the y. Negative x equals y squared. So it's negative x minus y squared equals 1. Nope. Different sign, same. So as long as one of them is different, it's no good. So you do your origin. Negative y squared equals 1. Stays negative x. 3 negatives is a negative equals 1. X's are different signs. Not symmetrical. All right. You remember how to graph these? This is actually one of those curves. It's y squared equals, what is it, x minus 1. That's why we're shifted over in here. And we'll learn how to shift this and graph these later. But as you can see, if I wanted to, it would be symmetrical down there. Got it? Sketch the graph. There you go. There's my symmetry. Sorry, I got that on.
No worries.
Thank you, Echo. Sketch the graph. Set y equal to 0. Or the graph that you're taking x out.
I can't help with that.
All right, so you take the x out. Set x equal to 0. 2x plus 1 equals 0. Subtract 1. Divide by 2. X equals negative 1/2. So that's negative 1/2, 0. 0, 0. That's negative 1, so negative 1/2, 0. Y-intercept, set x equals 0. Obviously, it's 0, 0. Same right here. All right? Symmetry. Y goes to negative y. Obviously, it's different. Y-axis, x goes to negative x. So this case, though, negative x squared, positive, and this stays negative x. The same, different. So just because one of them is different, it's no good. Okay, they all have to be exactly the same, so it's not symmetrical about there. And then you do the origin, negative y and this stuff. You get negative y equals 2x squared minus x. Different, same, different. No. So if I want to change it around, y equals negative 2x squared. Notice the sign's different. It is not symmetrical about the origin. So your problem doesn't necessarily have to be symmetrical. All right, this is a parabola. If I was going to graph it, and as you can see from this picture, it's not symmetrical about the x, not symmetrical about the y, not symmetrical about the origin. All right? Don't always think everything has to be symmetrical. All right, so we go with this stuff. Awesome. Finding points of intersection. Find all the points of intersection in the graph. Do you guys remember this? This goes back to algebra, which was either 8th grade or 9th grade for you. So, finding all the points of intersection in the graph. I think 8th grade probably. So you're going to solve for y in both equations. Now, step 1. How do you solve for y? I have to subtract x squared from both sides. I don't want negative y, I want positive y, so I multiply both sides by negative 1. So I just change all the sides. Positive y equals x squared minus 3. Solve for y right here. How do I solve for y? Subtract x, and once again, multiply everything by negative 1. Change the sign, change the sign, change the sign. Y equals x minus 1. Now, both equations both equal y. So what can I do to both equations? I could set them equal to each other. So y equals x squared minus 3, which equals x minus 1, which equals y. All this stuff equals each other. So all I really care about is the middle. I go, okay, I know that x squared minus 3 equals x minus 1. Now, do you guys remember how to solve these types of equations? Hopefully you do. You have to set up a quadratic. You have to subtract an x from both sides. So x squared minus x minus 3 equals negative 1. And then when I do that negative 1, add it to both sides. X squared minus x minus 2 equals 0. I have to factor this. What are the factors of negative 2? That add up to negative 1. X minus 2, x plus 1. Negative 2 times 1 is negative 2. Negative 2x plus 1x is negative x. So I set both of these equal to 0 now. X minus 2 equals 0. So x equals 2. And x plus 1 equals 0. And x equals negative 1. Just in case you're wondering, I added 2 to both sides here. I subtracted 1 to both sides here. So I have two x values. Now in order to find the y values, I take these x values and I plug them into which equation? It doesn't matter. This equation, this equation, this equation, this equation. They're all the same. I chose this equation because then I don't have to square anything. So, if I plug in 2 minus y equals 1. Alright, subtract 2 from both sides, divide by 1, and y equals 1. If I plug 2 in here, 2 minus 1, it's 1. 2 squared is 4, minus 3 is 1. Alright, you're always going to get 1. So my equation is 2, 1. Next one, I plug in negative 1. Negative 1 minus y equals 1. Add 1 to both sides. Negative 1 equals 2. Divide by negative 1, y equals negative 2. Negative 1, negative 2 is my 2 points of intersection. So those two graphs meet at these 2 points. And there you go. All right, this is just working on our equation manipulation stuff. Got it? Ready to do another one? We're almost done. Oh, actually, we are done. So that's the lesson. Hopefully, you use all this stuff. Interpret mathematical data. And we're going to get to that later on. That's the only thing we really didn't do. Not coming up in the new lessons, but able to sketch the graphs, all these works. So hopefully you had a good day. And if you didn't, just look over this stuff again. Have any questions? Come see me, ask me. Email me. All right. So until next time.